So this morning I am walking up the Tongariro Crossing. So started quite early, it's quite wintry, and my intention is to get as high as I can up towards Red Crater and then perhaps come back down the same direction. So this is the Tongariro Crossing track. It's pretty empty today because of the wintry conditions, and I'm going to be talking a little bit about the landforms and the geology that you see on the way up the crossing. So straight off up after the car park, when you look along the side of the track down here, you can see white coloured pumice. So this pumice is not from actually nearby volcanoes. This is pumice from the Topo eruption in AD 235, and if you look carefully at the pumice, you can see in places there are little bits of charcoal. So this pumice was erupted from Lake Topo, and the eruption basically was such a massive blast, it sent all this pumice across the countryside. It actually completely frazzled the forests in about 100 kilometres in all directions, and that's evidence of that eruption. So when we see pumice on the ground on the Tongariro Crossing, that is telling us that there's a bit more. So when we see that pumice, it's telling us that the ground surface that the pumice is resting on is about 1800 years old. That means if we don't see pumice, that means the layer we're standing on is more recent. The very first place I want to stop and talk about the Mangatepopo Valley here. So what we have is right in front of us on the right this dark shape of a mountain, and in the back the white peak of Narahoe volcano. So this mountain in front of us is called Pukekaikiori, and it has an interesting formation because it is made up of a series of huge lava flows that erupted during the ice age previous to the most recent one. So something like 190 to 130,000 years ago, there was an ice age, and there was on this side to the left here a huge glacier coming down, hundreds of meters thick, and also the same here on the right, there was a glacier. And so this, as this lava advanced, it butted up against these two glaciers and couldn't advance any further. So it built up this huge sort of monolith that sort of like it was dammed up against the ice. And then later on, higher up the top there, the snowy part of the hill, that snowy part is a scoria cone from a more recent eruption on top of the earlier huge lava flows. So to the right here, or now there in front of me, you can see a ridge that becomes a skyline ridge. And that ridge has a completely different origin. That's a moraine. So once upon a time, the Mangatepopo Valley, actually relatively recently, was also glaciated in the last ice age. And on the left here, we can also see a ridge. That's the other wall of the glacier valley. So that's a moraine wall there too. And so the glacier came down here, and it would have made, at the very end, a huge terminal moraine, but that has probably been washed away by rivers as the ice melted and just washed out the moraine there. So the two remaining moraines are the lateral moraines on either side. That's the one, and then if we continue around slowly, there's the other lateral moraine. So we're in a U-shaped glacial valley. And as we go further, as we continue, we will see that this U-shape has been sort of filled up with lava flows more recently. So it's more flat bottomed than U-shaped bottomed, if that makes sense. So just coming up to this sign here, reminding us that These mountains are sacred to the Tuwharetoa people, and so we are welcome to be here and also asked to be very respectful of our attitude as we walk through these huge ancient peaks. And we're approaching the band of lava flows that block the valley there. And Puke Kaikiori is now getting a bit of the morning sunshine. Here on the left is some layered deposits and also some pumice. So we are still... Actually, that's amazing. Well, that is ice. And this ice has formed just below the soil surface, freezing the water and expanding and pushing upwards. So this is a whole layer of what is called frost heave. And you can see, that's a perfect example. You can see how it has frozen on at the bottom there, and as it's expanded upwards, it has pushed the soil up in front of it. So it's lifted up a layer of soil, which means that you have this very hollow soil layer that's been pushed up by the ice. Fantastic frost heave, and there's several layers of it here. How cool. So that's frost heave, and then down just beside the track here's lots more pumice. So this is telling us that the layer that we're on is older than the Topo eruption 1800 years ago. And as we go up to the lava flows just there, we can have a look for pumice, but if there's no pumice, that tells us that those lava flows are younger than 1800 years. So the track is following up the side of the lava flows, and so here's a good place to actually see a cross-section through a lava flow. There at the bottom, if I just get a bit closer, that is soil. So the lava came on top of that soil layer. So that soil layer developed on top of the previous lava flow. I guess it'll be hundreds of years old. And then as you go up, you can see that there's a sort of very clean, massive section of lava in the middle. And then as you go towards the top, it breaks up into very rough, blocky, jagged lava called A'a lava. So that middle bit, I think, had a lot more time to cool down. So that gave it a chance for the gas bubbles to escape and for the crystals to develop more fully. And it was less chilled on the sides of gap cracks and that sort of thing. So a lava flow in three pieces: the base, the middle and the top. And now we'll carry on the track. Let's see what the view looks like up here. Vegetation around here is not quite so lush. The sign's telling us to go if the weather's good, turn back if the weather's not good. Looking good today. No footprints on the track. I'm coming up to a gap here between the lava flows. So looks to me like this flat area is a debris flow that has come off the slopes of Ngarahoe over there, from a couple of gullies, and swept down here, covering this area with bits and pieces of lava, blocks and ash and whatnot off the slopes of the volcano. So when the volcano deposits its material, it's very loose. There's layers of ash, very soft, quite solid chunks of lava, and the whole mixture is a bit unstable, so it makes sense that it would be susceptible to the occasional avalanche coming off the side of the mountain. But I think it's actually quite interesting as part of the erosion of the volcano. Narahoe is believed to be about 7,000 years old. Previous huge volcanic eruptions occurred going back over 100,000 up to 200,000 years ago, and lots of the remnants of those previous volcanic eruptions have been eroded away, probably by the ice in the Ice Age. So this is a little recent pimple in terms of the volcanic history of Tongariro. It was a very active volcano for most of the 20th century, and then it has been pretty quiet since the 1970s. So I've come up to the head of the valley. So this is where the track goes up a bit more steeply, and there's a little bridge here. So there's a cliff there of old lava flows, and what I think is so cool is that conical snow-covered kind of pile of debris is a bit of the lava flow that came down more recently and went over the top of the cliff. So it would have been amazing to stand here watching lava pouring over a cliff and piling up in a cone like that. So I'm coming up the head of the valley, sort of on the slopes of Narahoe. There's a trail going back, and there's the Mangatepopo Valley. You see maybe Mount Taranaki in the distance, far away. There are about two people still following me down there. At the moment I have this trail to myself, which is very cool, and it's actually not too snowed up right this bit, so quite easy. What there is here is super cool. You can see that this there's a track coming down off the slopes of Narahoe with these ridges on either side, and so they've been piled up. Here's one of them, piled up blocks of lava, and so somehow or other, as this material has come surging down the mountainside, it has created these ridges, and there are a few of them on the way up, but this one's quite good. So there have been pyroclastic flows coming down here, there have been lava blocks coming down here, and I'm wondering whether you can tell me, how do these levees form on the side of a volcano, on some sort of area where there's been a flow down the mountainside? Why would it be that on either side of the flow there's a ridge, quite a high ridge, and the middle of the flow is lower lying? So maybe that's a mystery. Maybe you can tell me how that could happen. Wind is picking up as well. It's often very windy on this col up here. Looking forward to seeing what it looks like. Whew. This really is great. Still plenty of time, plenty of daylight. So I'm walking across South Crater, completely deserted, and I'm going towards Red Crater, which is up on the skyline ridge there. A bit of hard work in these drifts, but I think they're not very many of them. And that's where I'm going. That's the trail up to the skyline ridge, which is near the Red Crater. So, the Red Crater in snow. wind up here, but I found a little knob thing to hide behind, so that's great. I'm right on the top of the Tongariro Crossing here, the high point. So I'm going to brave this crazy wind, and it's only 11:15, so that gives me quite a lot of time today. So I'm going to go down the far side of Red Crater to the Emerald Lakes, which will be frozen over, and so they will be the White Lakes. But it's going to be interesting in this wind. Definitely quite steep. So, I have made it alive down the far side, or the Ketitahi side of Red Crater, which is that white ridge coming down from there. It was very windy and I had to be very careful because the slope's very steep, but luckily I took my time, and so I'm down here now at Emerald Lakes. So one Emerald Lake is just over that ridge at the bottom of Red Crater there, and the other Emerald Lake is down there with a little bit in the middle that hasn't frozen over, which suggests it's a little bit warm. And then behind me there's a fumarole with some steam coming out, spread out across Central Crater here. You might be able to see some ridges of lava, sort of dark shadows. That's a lava flow that came out of Red Crater within the last 10,000 years. So I'm going to go that way towards the Blue Lake, which you can't really see, but it's just straight ahead. And then there is North Crater Tongariro in the distance, that flat thing on the skyline. After midday here. So, I have just finally left the Tongariro Crossing track. North Crater is a big flat crater about 1 kilometre across, and it's believed to have been a lava lake at some point. So the whole thing was a seething, bubbling lake of lava, and it eventually solidified, and so we have this big flat desolate area. I've been up here in the summer before, and I actually camped up here once, and it's really beautiful. But here we're in the winter, it's covered with snow, it's completely different. Since the lava lake congealed, solidified, there were 2 explosion craters blasting through it. One of them is really hard to see. It's that area there. You can just see a depression, maybe, surrounded by a few rocks sticking up. So that's not a very obvious explosion crater. But over here we're going to come up to a much bigger one, a more obvious one. So that's where I'm heading next. What I absolutely love about the North Crater is it's actually very close to the Tongariro Crossing, but I don't think people ever come up here. It's that feeling you get in New Zealand quite often. It's that there are parts of New Zealand that just people don't go to because they're not the main centre of attraction. So Tongariro has areas where you can explore respectfully and find these wilderness areas. There it is, quite huge. Must be 200 or 300 meters across. And I don't think I feel like climbing down into it today. My legs are very tired. This rock is going to be a seat. Quite amazing, this huge forgotten crater. Just one of the many features on Tongariro, some of which get seen, but this one quite rarely actually. So for a minute I'm just going to be quiet and listen to the silence. Yeah, just coming off the side of North Crater. I'm in the gap between Tongariro Peak up there and North Crater Rim, which is over there. Just up to my legs if I can make it. I'm very pleased with having bagged this extra little detour for the view here. I hope you appreciate it. It was hard work for my legs. And now it's downwards all the way from here, which is a bit of a relief. But it's been a great day. I only expected to get to Red Crater and then I thought I'd be turning round, and then I just felt like carrying on down to the Emerald Lakes, across Central Crater up to Blue Lake, North Crater and the explosion pit, and then up here to Tongariro Peak for this fantastic final view. So there is Tongariro Peak, and I've just come down, and now I'm on this rocky ridge here which goes down that way, and on the left of it is the Mangatepopo Valley. You can see in places the track that I came up this morning, and there are the slopes of Narahui, the levees coming down, the lava flows, the big cliff that we went past, and that's it. So I think from at this point I'll say farewell, and I hope you've enjoyed this little excursion into the white winter wilderness of Tongariro. Beautiful place. There's so much to see. There's so much exploration to do. If you've enjoyed the video, click a like, make a comment, and I look forward to seeing you in the next one.